Let me give you a brief overview of quality control for e-compressors project. There are over 40 unique components in the design of electronic compressor, each of which can contribute to NVH at some level. NVH stands for noise, vibration, and harshness. The compressor team has encountered a range of noises including rattling noise and mechanical resonance. The problem is traditional data processing cannot consistently detect those NVH failure. It's hard to detect and they are expensive to run. So let's have a look at actual data. This is audio file and this is a graphical representation. I turn the sound into graphical representation. So the size is 851 by 558. The sample size I'm going to demonstrate is fairly small. Sample image has 28 by 28 size. By one channel, black and white. I calculate the threshold like this, mean value plus standard deviation. If we want to go for 3 standard deviation, we can write like this. Then the threshold is 0.012. You need to remember this. Let's open up a sample image, which is 28 by 28 size. Let's calculate the loss rate, which is 0.11. So the threshold was 0.126. So the image is below the threshold. Then let's open up the image file again and mess it up a little bit. Save. I will open it up again. And this time, the image has been done. Then let me calculate the loss rate again. So it's above the threshold. The threshold was 0.012, but this time the loss is 0.02. So this is the gist of it. I'm going to calculate the deviation. If the deviation is above the threshold, it is considered outlier, defective product. That's basically the gist of it. Thank you.